When you look up at the sky and see clouds floating peacefully above, have you ever stopped to wonder, how do they stay up there? They look so soft, so light, almost like cotton candy or fluffy pillows drifting in the air. But here's something surprising. A single cloud can weigh more than 500,000 kilograms. That's over 1 million pounds, or the weight of 100 elephants. Now ask yourself again, why doesn't that enormous mass fall down? To answer that, we need to look beyond appearances and dive into the science behind what clouds are and, more importantly, how physics helps them stay afloat. Let's start with the basics. What are clouds made of? Clouds are not made of smoke, mist, or anything magical. They're made of tiny water droplets or ice crystals, formed when water vapor in the air cools down and condenses. This vapor usually comes from oceans, rivers, lakes, or even the surface of leaves after rainfall. As warm air rises from the ground and carries the moisture up into the atmosphere, it cools. Cooler temperatures cause the water vapor to condense into minuscule droplets, so small that you'd need a microscope to see them. Together, trillions of these droplets group up to form a cloud. But how can something made of water, even tiny droplets, just hang there in the sky? That's where physics comes in. The secret: size, air resistance, and upward motion. While a cloud might contain tons of water, each droplet is incredibly tiny. Their small size means they have very little mass individually and are easily affected by air resistance. This resistance slows their fall, keeping them suspended in the atmosphere for long periods. Think of it this way. If you drop a feather and a rock from the same height, the feather falls much slower because of air resistance. Cloud droplets are even lighter than feathers, and air keeps them afloat, just like how steam from boiling water rises and drifts around before disappearing. But that's not the whole story. Another important factor is updrafts, columns of warm air rising from the Earth's surface. These updrafts provide a gentle lift, helping to counteract the pull of gravity on the cloud's droplets. As long as the upward force from rising air matches or exceeds the downward pull from gravity, the cloud stays in place. This balance is delicate but incredibly effective. It's why clouds can float at different heights and sometimes appear motionless, even though they're constantly changing internally. But why don't they fall as rain? Clouds do fall, eventually. As time goes on, the tiny droplets in a cloud can collide and merge, forming larger droplets. Once they become heavy enough, air resistance is no longer sufficient to hold them up, and gravity pulls them down as rain. This process is called precipitation, and it's how water from the atmosphere returns to the Earth. Interestingly, not all clouds produce rain. It depends on factors like humidity, temperature, wind, and the structure of the cloud itself. Some clouds stay suspended for hours or days without releasing a single drop. The role of cloud types. Clouds come in different shapes, sizes, and altitudes. Some float high in the atmosphere and appear thin or wispy. These are called cirrus clouds. Others are thick, heavy, and darker, like cumulonimbus clouds, which are often responsible for thunderstorms. The higher and thinner a cloud, the less likely it is to produce rain. These clouds contain ice crystals and are held aloft by powerful jet streams and temperature gradients. On the other hand, low-altitude clouds, especially the dense, gray ones, are more prone to forming rain. So, why do clouds float? To sum it up, clouds float because the droplets inside them are extremely small and thus fall very slowly. Air resistance is strong enough to counter gravity at that scale. Rising warm air, updrafts, provides continuous lift to keep the clouds suspended. Cloud structure and atmospheric conditions allow this balance to be maintained. It's a perfect example of how something seemingly simple is actually the result of complex interactions between heat, water, gravity, and air pressure. It also reminds us that not everything is what it seems. Just because something looks light doesn't mean it is. And just because it's floating doesn't mean gravity has disappeared. In fact, clouds are a great demonstration of how gravity, buoyancy, and thermodynamics work together in harmony. Pretty cool, right? Want to understand more about how nature really works without the boring textbooks? Watch the full video now and let Meena explain it all in a way that's fun, simple, and fascinating. And don't forget to like, share, and subscribe to Wiseuse for more smart content like this.